Dean of Research. Currently, he's working as a Dean of Research over there. He is also a research advisor in NASS Singapore. Uh, he has so many publications at national and international journal reports. He has guided so many PhD students, MTech students, and also BTech students. He is currently working in various national and international projects as a principal investigator, and his area of research is application of numerical analysis techniques like machine learning, artificial intelligence, optimization, system modeling, and simulation, and fractal dimensional analysis in order to improve prediction and automatic expert diagnostic models for biomedical area using data and feature extracted from mainly digital images and signal processing. So, thank you very much, sir, for accepting our invitation to deliver expert lecture. Thank you, sir. Over to you, sir.
Thanks to all of you, especially the organizers present over here, Professor Vinit Kansal, Dr. Pawan Kumar, Dr. Upendra Kumar, and my other colleagues present over here, and the participants, learned participants, who are also in the same boat with me to discuss these issues of artificial intelligence. A part of that is machine learning. So let me actually share my slides and go on discussing this matter. I want to discuss with you because I think that we are in the same boat. We all are learners and we have some sort of initial introductory knowledge of artificial intelligence and machine learning. So obviously it will be a discussion and I will stress on the fundamental aspects of machine learning, which is a very important part of artificial intelligence. And I feel that we should repeatedly come back to the fundamental aspects of these subjects to actually brush up our memory and also to actually re-energize us. Means what happens that when we look at the tree, then we forget about the forest, and when we look at the forest, we forget about the tree. So repeated visit to these two parts of this subject, that is the advanced part and the fundamental part, I think it is not a bad thing. So, and this is the beginning of this particular FDP. It is a quite long stretched FDP. It is the beginning, so there is no harm in discussing the issues, the fundamental issues related to this artificial intelligence and machine learning. So let me share my screen first. I got the material. I'm sharing the screen.
उपेंद्र जरा देखिए क्या प्रॉब्लम है सर, क्यों नहीं शेयर कर पा रहे? नेहा?
No,
now it is coming, sir.
It's not a problem. It's not a problem. I'm finding the material actually. Yeah, I think all of you can actually can get the thing right now. Can you visualize? See the means shared screen?
नहीं सर, अभी स्क्रीन नहीं दिख रहा है आपका.
No. Sir, I think now it is coming.
Just one second.
No.
Let me reshare the screen.
Sir, there is a share button, just bottom
button. I am sharing from there.
Bottom middle portion.
Yeah. Should I actually keep the files some in some Google or somewhere else? I think sharing
sir,
screen.
No, sir. Actually, it is, sir. It will ask you to share the screen. Once you will click on the share button, it will ask to share the screen. So you can share the whole screen or part of the screen also. And sir, have you opened your file, PPT file?
Yeah, I have opened. Just once again. Let me check the thing again. Actually, it is asking whether I have to, I want to share the files from the whiteboard or from some other means. It is asking. Let me see.
नेहा जरा देखो क्या दिक्कत है.
Okay, understand.
Sir, please. Okay.
Okay,
No.
okay. Now I think my
Thank you, Neha.
screen is visible.
You may open the.
Yes, yes, sir. It is visible, sir.
Fine. Actually, we are not accustomed with Zoom because of our official prohibition on that. So sorry to actually, sorry for the inconvenience. Well, now I think it is visible, isn't it?
Yes, sir. Visible. Yes.
Clear, sir.
Okay,
It's clear.
Okay. So the first point is actually, let us revisit and discuss the matter again. We all are learners. So the thing is, when we are talking about this artificial intelligence or machine learning, normally, if somebody asks that, what is the requirement of doing all these things? What is the necessity that is driving you that you should learn machine learning or artificial intelligence? If it is asked to somebody, then what we find that normally, well, the people within the biology area or medical science area, they will say that, oh, it is helping us in diagnostics, automated diagnosis. If it is kind of the field of electronics or information technology, they will readily actually give the answer that to have some smart machines like smartphones. So these are very vague sort of answer. We should understand means what we want to do. Our objective should be very much clear to my view. So in that sense, this machine learning fundamentals, while we are actually revisiting that, we should start asking that what is this artificial intelligence? And after splitting, going into the deep, what is artificial? Then what is intelligence? Then in case of machine learning, what is machine? What is learning? So all these things is actually forming our philosophical background to make us interested to know this subject more, as well as, to my view, to understand the application and utility of this particular area for my requirement, means whatever problem I am dealing with. So in that sense, if it is to build a machine that should be as intelligent as human being, then obviously the goal, we all know, the development of the field of robotics, it is a non-ending story still now. Still now, officially, we all know that it is quite difficult to build a robot, to make a robot, even with a capability of, means intelligence capability. I am talking about intelligence capability, means brain-wise, in this application of intelligence, equivalent to a mouse brain. Still, we could not create a robot of this mouse brain. So we should actually think twice about this field of robotics. Right? We beat our chest that, yeah, there are a lot of developments in the field of robotics. So what is there? What is the fun of actually doing all these things? Although there are many good applications also, but those applications is not actually defending our claim that really we have progressed we have made a sufficient progress to build a machine that is equivalent to a human being, especially intelligence-wise. So that is one thing. Another is actually, what is artificial? Why we are referring intelligence as artificial? if we look back to the means root of this intelligence, we know that it is the criteria of any living being. And then the functionality of this living being associated with its intelligence is not making this intelligence anyway as artificial. Just think about the monkeys. Monkeys can actually jump upwards, deferring the gravitational force. So that is, in some way, we can refer it as an unnatural sort of activity. It is not natural. It is unnatural, so it is artificial. Is it so? No. We all know that this is a very particular thing that is within the nature of the monkey, that they will actually jump upwards, defying the gravitation. But that doesn't mean that it is defying the nature or the natural sort of activity. So this is the means kind of quality of the natural quality of the monkey. Similarly, when a bird is actually forming its nest, then we refer it as natural. But when we actually come back to the human being, the matter of human being, when a human is actually forming a house, we refer it as an artificial. This house is not natural. It's not a means activity which can be referred as natural. This house is a fallout of the artificial sort of activity. This house is artificial. So we forget to think that it is within the nature of the human being to actually means make some house, to build some house, to build so many things. And it is within their nature, within the capability of their natural brain, they are doing all these things. And that should not be referred as anyway as an artificial activity. Similarly, when we actually refer this artificial intelligence, although we know that intelligence in many ways can be actually defined as only a natural sort of aspect of any item, intelligence can be referred as a natural aspect. And also for such particular interpretation, when we are thinking about intelligence, this machine learning or artificial intelligence, in the context of artificial intelligence, we should stop debating on all these things, because this is actually diverging the whole thing towards a philosophical module that is beyond our scope. So better to come back and to actually look at the convention, what convention we follow to describe something artificial, especially artificial intelligence. So we all know that it has been started from the days of Alan Turing, when the main objective of this artificial intelligence, the subject of artificial intelligence, was to build a machine which will be as good as a human being from the angle of application of its intelligence. Means whatever error the human will commit, the machine will also be expected to commit the same set of errors. So that was the goal initially. But right now, the goal of artificial intelligence, we are actually somehow, we are moving away from this philosophy, and we are actually focusing on small sort of aspects of this artificial intelligence. If it is very useful for us, why not? We can think about the advantages of utilizing of all these aspects of artificial intelligence, instead of thinking of the whole gamut or whole scope of this artificial intelligence to consider. So current advent of artificial intelligence and machine learning, these subjects are very old, but the current advent is actually because of this reason, to my view, that if a small utility can be considered as a very smart one, why not we can go for that? And if that is very useful for us, we should focus ourselves to actually apply this particular utility of this artificial intelligence to actually achieve our objective.
Sir, excuse me, sir. Sir,
Yes,
sorry to interrupt you. Sir, slides is not moving. I think.
slightly, yeah, I have kept it intentionally in the
Okay,
first
okay.
slide.
Then
I
it's
will
okay.
move, I will
Okay,
move. Don't
Then
worry.
it's fine, sir. Fine, fine.
fine.
Okay, okay. I will move. So, well, it is moving. To prove it, I did it. So the next thing is to discuss about the system. So while we are actually dealing with these two subjects, we are dealing with systems. Everything we are doing for the benefit of our system of interest. Whatever system is there, either we are want to make it very smart, the system, or we want to know or explore these systems more. So obviously, this subject, we all know that it falls under the very important area of systems engineering. What is systems engineering? In the context of systems engineering, we should know the examples. We can know it very well from the examples. The examples are like a missile. Missile is a system, and we suppose we are building a missile and we have some objective to accomplish, that this missile should have the range of this much of kilometers. This missile should have a range of, the missile should actually follow a path, something like that. And the missile, yeah, these are the basic functionality. I'm not going into the intelligent part. If those are the targets, then we must have to find out what are the system components, the subsystems, which are actually contributing to fulfill those objectives. What are the system subcomponents? It may be the material of the surface of the missile, because if it is not a proper material, then it will burn out. So it should not be something like that. So heating should be considered. And you can understand so many other aspects are there. So we have to find out which are the particular system subcomponents which are very much important. We refer those subcomponents as systems variable. So once those important subcomponents are actually found out, then we refer it as systems variable. Then obviously we can think ourselves as king or queen, because the particular system variable which are actually representing that particular system to fulfill our objective, the initial task of building any intelligence system is that only, to find out those very important system variables which are affecting our purpose, which are actually helping us to fulfill our purpose. So this is a particular task we find that is defined within the scope of the systems engineering. So in that sense, systems engineering is very, very important to know. And you will find, if you go through the definition of system engineering and the scope of the systems engineering, you will find that obviously there are the highlights of this systems engineering. To know the highlights, we can understand those highlights are nothing but, number one, optimization, systems optimization. Then actually systems modeling and simulation. And third one is actually this system, how to make the system smarter, that is machine learning. Machine learning is also falls under the jurisdiction of this systems engineering only. And all these subjects, the mother of all these subjects is, as shown in this slide, subject jurisdiction. I have mentioned over here. This jurisdiction is mathematical science. There is a great argument among the mathematicians that whether it should be considered as science or a non-science sort of subject. Then comes the advent of mathematical science. If you are actually using this mathematical means equations and all the means kind of mathematics as a whole, you are applying it to fulfill your objective, then it is referred as mathematical science, means applied mathematics only. So this systems engineering, the part means components of this branches of this systems engineering are these three, which can be tackled with the help of this subject of mathematical science. And which kind of mathematical science? We all know the branch of mathematics that is dealing with theory of approximation. Because in real life, we need an approximate solution, not an exact solution. So for that reason, the theory of approximation is helping us. And finally, the subject area that has been descended from this theory of approximation is the numerical methods or numerical analysis. So finally, we understand why I am discussing all of these things. The convention to describe the artificial intelligence or subject machine learning is something, and for our application in a bigger way, for our application, we should know about the actual essence of this subject, which is nothing but to build the computational model only. Building a computational model is a very old exercise. Machine learning is also quite old, but the objective for different sort of computational model are different. Like one computational model is actually having the goal of doing some sort of simulation, systems modeling, to know system and to know what kind of variables are very important for this system. So it is actually referred as systems modeling. And for this, after knowing all these system variables, then to actually optimize the performance of the system, that is actually under the subject of optimization. So all these are nothing but computational model. Similarly, this machine learning is nothing but, please take it from me, for application sense especially, this is nothing but a computational model only, simple computational model. Take it like this, then everything will be fine. Our goal for every computational model, our goal is to define this computational model first. So suppose we are dealing with machine. So to define this computational model, we should know what is machine in case of machine learning. So in case of machine, in this machine learning, now we understand that this machine, obviously that it will depend on the goal. If we want to make the machine smarter, then obviously it will be referred as a smart machine only. And how to make a machine smarter? If we ask this question, then obviously by injecting our intelligent model, which is actually a computational model, which is equivalent to serving the purpose of intelligent task. So that will be referred as a machine. So either it is actually a smart machine, or it may be a kind of computational model that can be injected within the machine to make it smart. So for our use, we can think that this machine is nothing but the computational model that is actually going to make this machine smarter. And if we think that this machine is nothing but it is going to be referred as an intelligent system, so obviously our computational model should also serve the purpose of representing itself as an intelligent sort of entity. So for that very reason, let us start with a very, very fundamental aspect of the mathematics. We refer it as y equals to fx. What is this? It is very, very intriguing or interesting to find out that this simple equation is actually representing so many things. Y equals to fx, we all know. The mathematical meaning is actually to give an input of x, and then the x will be mapped into a different entity through the help of this function, this f. And if we just extend its scope, this f, we find that f is nothing but we can represent it as our model, as our machine, whatever you can refer it to serve your purpose. It is something like that only. So this f is actually representing the system which we want to make intelligent. So this system f is taking input x because that is the means particular nature or property of any system. So any system, it may be in living system like human, it takes an input. When it observes something, that means it is taking the visual input. When it can feel something, it is actually taking the sensing input, sensory input. When it is actually listening something, that means it is taking an audio input. So, and then obviously we perform some task. We listen something and then perform some task. And performance of this task is nothing but to produce our outputs. So that is nothing but this y. So in that sense, this very simple equation, y equals to fx, is so important. Next is actually the question that what is learning? Now, we all know that learning is nothing but standardization process, which gives a good estimation of f. So in that sense, sorry. So in that sense, it is very simple thing. Learning is nothing but, if we go back to our very old standardization process, so learning is nothing but this standardization process only. So what is this standardization process? I am just giving you one such example of standardization process. A very crude example. In the field of engineering and in the field of any other means technical sort of field like science and mathematics, everywhere we do this type of standardization. If we are actually dealing with the real life problems, like suppose one such problem is to measure the blood sugar. If we just be very inquisitive, very curious to know what is going on to actually measure this blood sugar level. So experimentally, it is something like to prepare a solution within which you will put your sample blood of same volume, and the solution is will be also of same ingredients with same concentration. Everything are same. Only difference will be the sugar within the within your sample. And in accordance with the means amount of the sugar, it will form some color. So from the coloration, you can understand what is the level of this blood, what is the level of this sugar, blood sugar level. You can readily understand, you can readily measure. So for measuring this coloration, there is some equipment. It is called kind of spectrophotometer, and which actually measures the optical density. So you will get the optical density value while you are measuring the color. You will get the optical density value. So optical density value and blood sugar level. So if you just have some sort of samples with known amount of sugars, some few samples are like this, like whatever I have shown over here, 5 samples, 5 points are generated, and then obviously it is actually making a plot, and optical density we have measured, and we understand that it's not a kind of simple plot. The points are actually something which are the result of the real life problem, and you cannot think of any kind of curve that can fit to these particular points, all these points. So we are actually eager to know if there is any sort of straight line. That is the simplest solution to actually represent all of these points. So we are actually taking a straight line and we are moving it, rotating it, and we are trying to find out the best position of this straight line for which all the points will be very close to this particular line. Means the error will be very less. So this is the standardization. So if we focus on this standardization process that we were doing from time immemorial, then we are finding what? A very good thing about machine learning, that for any such standardization through which we are taking the decision of blood sugar, see, what is the input? If we again represent it as y equals to fx, then input is optical density. After actually getting obviously this means particular sample with unknown amount of sugar, while you are actually putting it into this spectrophotometer, you are getting the optical density. So, but optical density is not actually telling you any direct sort of information it is giving you about this sugar level. So obviously, this can be considered as your X input. And your model, there should be a model. Here, this model is nothing but your straight line, which can be referred as y equals to mx plus c. And while this m is very much known to you and c is also known to you, then obviously there will be no problem. Given the value of x, you can readily take your decision about the blood sugar level. So how we are doing it? If we just go through that, it is nothing but a kind of training. Initially, we have collected the sample with known amount of sugar. That is actually forming our protocol of training. And with this protocol, with this training set of data, you can define it perceptually or any other means, but actually we are actually searching for a model which can actually tell us from this set of known data, what will be this model which can give you the answer for the data for which the answer is not known. So this is the simple sort of framework of machine learning we can learn with the help of this simple standardization or curve fitting itself. So this is machine learning. In a very simple way to understand, our goal is to compute, and it is nothing but a kind of standardization in its simplest form, and that we are doing over here. And obviously, then the next question will be, So what is the fun of actually discussing of all this machine learning sort of thing while it's a simple standardization, while it is the same thing, same old thing to do, then what is the fun of actually discussing about this machine learning? So the answer is then can be found out from the nature of our objective. Means what is our objective to fulfill over here? For any computational model, the objective is different. I have already told you that for optimization, it is the objective of find out the means the value of parameter for which the system will perform best. It will perform in the best manner, and the goal of this computational model related to this systems modeling and simulation is nothing but to find out the system variables and to build a model out of that, to understand how the system is performing, to produce its output. It may be any output with the variation of this value of these variables, how it is performing. So to build this model means this F. F is at that moment of that meaning only. So meaning of F is getting changed. And in case of machine learning, the goal is to classify. Yes. The goal is to tackle first, as shown in this slide, to tackle increased amount of degree of difficulty. The examples are multivariable problem, means X is not a single variable, and the output is also not a single output. It may be multiple output. And also the third one is actually within the first point, obviously. The third one is dealing with nominal scale variables. So this nominal scale variable is actually taking us to this particular area to think about a different computational model which can deal with this nominal scale variable. And I think we all know what is nominal scale variables. For the means means beginners, what should I say, that this variables can be of different scales like ordinary scale, then different scale, then nominal scale variables. So this ordinal scale means where actually you can have the comparison of the values, but you cannot add them. And then difference sort of scale is actually something like your thermometer, where you can actually have the difference of the values, but you cannot actually multiply or do anything with this. Then actually there is a scale which is nothing but this arithmetic scale, where you can actually do all the operations of mathematical operations is possible. Multiplication, division, all these operations are possible. And the beginning, I have intentionally omitted this particular scale of variable, which is referred as nominal scale variable, which is just names only. You cannot do any means arithmetic operation with this type of variables like names. We cannot add two names. We cannot divide one name with another name. We cannot multiply one name with another name. So like names. So the output is going to be some name tags. So for that very reason, the goal of computation is actually getting different. It is not to actually find out an output which is actually a kind of continuous sort of output. A function is not continuous. It is going to give us something, some output, which can be, we can actually again go back to the physics to understand it, that it is following the protocol of this quantum mechanics, from where we know that among all the possibilities, few possibilities are there which are really possible in a real life scenario, like orbits of atoms. So the energy of orbits, actually defining the energy at every orbit. So all the possibility of energy levels are not there. Few possibility of energy levels are there, which are referred as orbits. Similarly, all the decisions regarding our kind of system, I am again referring it as system. Suppose we want to identify a student, the student is of which particular batch, and we all know that there is a batch-wise color already defined for their dress. So if it is a blue color, then this student must be of a particular, suppose, batch of third standard. If it is green, then fourth standard, and so on and so forth. So obviously, we are going to have some sort of this type of decision, no in between green and blue. So it may be a student in between these two batches, no such possibilities we are considering. And in real life, we are actually dealing with this type of problems. To solve our problems, we divide the problem into some finite possibilities among the infinite possibilities. Means we are trying to define them as classes. The class of problem means, suppose for this particular Zoom webinar, suppose I want to actually find out which particular student is, or learner, I should refer, that he is not so much interested to know about my topic, then obviously who is actually living and again entering, and how much time, how much means how many times he is actually doing this type of thing, repeating this type of thing, then obviously I understand that if it is 1 to 2 times, then it's okay. If it is more than that, a particular threshold, then obviously I can actually refer the student as not so much interested for this particular discussion, and so on and so forth. So it's a kind of human sort of nature to define everything by forming some classes. And so this is the best thing to actually understand this particular computational model, that the target or objective of this model is actually to deal with the nominal scale variables. And also other factors are there, the automation of huge input data, example, digital image, genomic data. So from this data, means the task will be obviously, means if it is a not so huge data, then obviously the human, if you just go back to the means nature of the human, how the human try to define all these things. So if it is a small scale problem, human obviously try to understand the means classes. If it is a large scale problem, then obviously we do everything through our experiences, and experience means nothing but to actually present the input data repeatedly, different input data, but all those input data is actually leading to a class, suppose, class of information. So if it is so many data, then obviously it becomes difficult for us to fathom or to apprehend. Then obviously the very simple standardization may not work. First, we have to discover the knowledge. First, we have to find out the very crucial systems as subcomponent, means within this huge data, which particular set of data are really important for us. So we have to understand this, and that is actually making this particular subject very interesting. Then third is inclusion of human reasoning. Obviously, whatever I have already told, that to build these computational models, today, this is the practice. To build any computational model, we go back to our own brain aspect. We normally do some sort of introspection, and then obviously we try to find out means how we are actually trying to find out the answer of this, how we can understand that it's a mango and guava, how we are differentiating these two. Both of these two items are actually having the same color. In spite of this, how we can actually understand it very easily or very fast. Whereas when I actually giving this task to my model, computational model, after doing a lot of calculation and computation, it is giving a wrong answer. So maybe the mango is referred as guava and guava is referred as mango. So what is the basis of all these things? So this is the practice that we go back to our human reasoning and try to find out the answer. Next, as I have already told you, that we are actually doing this type of practice, that what we are doing, and try to have some sort of mathematical or computational translation of our activities or equivalence we want to actually build. And that is the basis of any computational model, and especially this artificial intelligence based machine learning models. So number one is actually, as I have already told you, that when we are experiencing a particular input data, so that kind of having some sort of experience can be referred as data collection. So we are collecting data, and then obviously when we are having the repeated experience of this nature of data, means we are passing through a particular area through our vehicle is passing through a road, and roadside some flowers are there. We found that the flower color is yellow color flower is there of typical size. They are not exactly same, but very much self-similar, and this self-similarity is very much evident for these particular objects. We can readily understand. How do we understand that we are actually collecting this data? We are keeping it in our memory, and we are actually comparing it, what this newly collected data with the already stored data, and through which we are actually, we try to get a kind of association between similar objects. So this association is very much important. I'm coming to that, but first task is to actually store the data within our memory, within our storage device, especially for computer. Number three is actually knowledge extraction and encapsulation from the experienced facts, that is data mining through grouping similar data. So what we do normally, we have a bucket full of, suppose, vegetables, tomatoes are there, then potatoes are there. So what are when we are kid, so what was the kiddish activity at that moment to understand that these are tomatoes, and these are potatoes. Although at that moment we may not know the name, but we can identify that from the self-similarity, one after another, if we actually pick these items one after another and can keep it at some places, then obviously we understand these items are very similar, to keep them in a same place, and what are different then at a different place. So it is like this only, and no supervisor was there at that moment, so we define it as unsupervised learning. Similarly, once we are very much learned, and we have a good amount of knowledge about the nature of the data. Data means it is tomato. I know very well that it is nothing but tomato, and this is nothing but potato. Then obviously, if we find some kid, then I can make him learn from this already acquired knowledge that is within me, that see, this is tomato, this is potato. So that tag, class tag will be there. Initially it was a grouping, then we are forming class with the help of a teacher, and that is nothing but the supervised learning. And next, in the step 4, we understand that all these things we are doing, which is actually helping us to identify whenever there is an unknown object in the sense that it is not actually there within the stored memory. So we found some, we have encountered, experienced an object that is very much similar to tomato, we identify it with tomato. Well, our decision becomes a tomato. Similarly, computationally or mathematically also, if we are talking about data, instead of the physical means existence of the data, if we just think about the data we are thinking about the system which is being represented by some featured data. I have already told you that we try to find out the system variable which are actually representative for this particular system to help us in this type of computation. So these variables are normally referred as features instead of raw data. Means if I actually have a means kind of image of this tomato, then obviously from this tomato, if we just think that we'll utilize this particular image only to understand that this is tomato, then obviously just think this image size may not be same, the tomato size may not be same, then so many things are there, among which we have to find out the particular data. It may be color, it may be shape, means data defining shape, then it may be the texture, so color, shape, texture, that may be very much important for us, or size. If we can extract these values from this raw data, then we normally refer it as system variable, which are very much important, and we refer it as feature also. So data at different level, raw data, then featured data. So from this featured data, we can obviously, then we can deal with this featured data to identify our object. And especially the very well-known example for this artificial intelligence based kind of system is nothing but the diagnostic system, where we normally try to define the disease. First, to define the disease, we normally get the clinical data. Then it may be kind of radiological data, and all are raw data from which actually we extract the feature. And then from this feature, we try to understand that this data is having a very close association with which kind of already stored data. And from there, means already stored data are there, means disease 1, disease 2, disease 3, for so many diseases, so many subjects, so many data are already stored, and we compare it. And then obviously we come to our decision that it is actually matching with a very closely matching with a already stored data, that is disease 3. So it is the disease 3. The decision is disease 3. So diagnosis is not actually kind of patented property of only medical field. Diagnosis, you can apply this diagnosis sort of mechanism for this automobile industry, where every car you will find that they are trying to understand the problem of the car. These days, all these cars actually are kind of mechatronics. The result of mechatronics, electronics and mechanical part are actually closely linked. So this automobile industry is also actually using this computer-based diagnosis of the car to find out the fault of the car, the disease of the car. So this is not actually the property of this medical field only, although the term diagnosis is actually came from this particular field only. So this is the task we can do through this particular computational model only. Don't forget that this is a computational model. Is as simple as that. Only thing is the why this output is different. It is of nominal scale output. So with this, next actually the concept of training and testing data. So obviously, once we build this model, if we have already built this model, then what actually we are going to do, we need to actually see whether this model is actually really good or bad. So efficiency of this model, this performance of this model, to see whether it is actually fulfilling our objective or not, test, we need to test this model. So already I have shown in case of standardization that we need a training set of data, that is data with known value of features, this outputs, then obviously we can have some other set of data for which also everything is known, but it is known to us, but it is not known to the model that we have built. So we will feed these inputs to this model and to see whether the same output, whatever is known to us, is being offered by this model or not. So with the help of this, obviously, we can test whether the model is right, correct, working correctly or not, or what is the efficiency of this model. Means out of 100 such test data, if it is actually giving the output for this test data 90% of times, means for 90 data it is giving the correct output, then obviously we can refer this model as having efficiency of 90% efficiency. So like this, we can actually try to see whether this particular model should be accepted or not by us. Like human also, you see, human is also having some limit of its ability. Then obviously, if somebody is coming, suppose a particular person, you are saying that it may be an animal also, very obese sort of, and actually coming with a very slow speed, and also the gait pattern of this particular person is also matching with, means from the dark light, brightness is very less, maybe it is just at the night with very dim lights are there, and you are trying to find out which is this particular object, is it an animal or a human being. Then obviously when it comes closer to you, then you understand, no, it's not an animal, it's our director. So it may be something like that. So this is the means particular thing we should understand, that human is also having, it is only just a hypothetical example. We should not, disclaimer, I think I need not put a disclaimer over here to avoid any sort of dispute, but it is only to give a particular example, hypothetical example, obviously. And through this, we can understand that what is the meaning of this efficiency. It is actually having some sort of error in actually giving this output, maybe 10% of time. That doesn't mean that we should discard it. If it is actually serving our purpose, that 90% time it is doing the thing right, and it is serving our purpose, then obviously we can consider to accept it. So that is depending on us. We have the creator of this model, then at that moment we are actually serving as God. So then we will see whether we will deploy these things, employ it or not. So that is, the deployment will be in our hand. Yeah. Now, as I have already told you, that this abstraction of input data, the data structure, we should be very much aware of this particular thing. So the dimension, the very important point is that we should be very, very much aware of dimension of the input data, that is the feature. This dimension should be always same. Dimension should not differ. So that is the main point. We should understand that when we are going to find out the association between this data, to understand whether two different data means from two different systems you have extracted this data, whether these two systems are similar, means these two entity, maybe two tomato are there, whether they are tomato or not, and they are actually forming a same group or not, then obviously you will go back to your extracted data to see whether they are closely associated or not. And close association means similarity. Similarity means nothing but inverse of distance. And then if it is distance, then obviously you have to calculate the distance. And if it is distance, then obviously the data should be.
Sir?
Yeah.
Excuse sir, so sorry to interrupt you. There is one question. There is one question from participant side.
Okay.
Uh, so the question is, what is the difference between supervised and unsupervised learning? Explain with example. So Gaurav Pandey is asking actually the
Okay,
difference
okay.
between supervised learning and unsupervised learning. Yes, yes.
Well, I'm just go back to this. I'm sharing the screen, and then obviously one particular photograph I think will make it very much clear. Let me deal with this photograph first. This one second. I think this photograph is very much visible to all of you.
Yes, yes, sir. It is visible.
Okay, okay. So this is a photograph. I have already referred
Visible,
that,
sir. Visible.
yeah, that there may be a bucket of vegetables and different types of vegetables are there. And suppose you just go back to your means childhood when you were an infant or kid, you have no idea about all these objects. It is you have seen it first time in your life. Then normally, if there are nobody means surrounding this place, closely close to your means surroundings, then obviously what happens that you will be interested as a kid to pick the items one by one. Then what happens that at that moment you try to find out the close association of these objects, isn't it? When you are picking tomato, tomato is visible over here, isn't it? So when you are picking tomato, then next time you are picking something else, maybe the sweet potato, then sweet potato and tomato, there are some differences that is very much means evident. It will be evident to you. And while you will do it, then it may be interested, means while you are keeping all these things on the floor, then next time, at the next step, you may be very much interested to actually make a group of all these items, just looking at the self similarity between these objects. And at that moment, nobody is actually present over there to teach you about these particular objects, means which object is of what type, means what is the name of these objects. Nobody is there, but you are actually slowly making some groups. So this is the unsupervised learning. And suppose you are within an island, nobody is there, and you are actually getting all these informations by your own, then you are giving a name of these objects. Then after formation of these groups, then it will be a task of naming of these groups. And you are naming that this is a tomato group, this is a sweet potato group, you have named these objects. Then if it is so, then if some other guy came to this island, he is also he or she is also having no idea about all these objects. Then you are actually showing this particular person that, see, this is a particular bucket is having only tomato. Then this is the tomato. This is the sweet potato. You are teaching him. So this is nothing but this supervised learning. That means when we have some data within us and we don't have the idea of the classes, no expert is actually telling us, means what is there within the data, how many groups are there, how many possible groups are there to be formed by this data, then obviously it is going to be a difficult task for us. Nobody is there. Forget about diagnosis and other things. Suppose the symptoms are there, and from these symptoms, you are actually trying to find out within the dark that what is going to happen, how to decide about the problem of this particular person with the help of these symptoms. Then obviously, what you will do, you will arrange these symptoms obviously you will organize these symptoms, value of these symptoms, you will list them, and then you will try to find out the close association between these symptoms, whether you can form some group of symptoms. Then obviously if it is a group of symptoms, then you can give the name of these symptoms, and by that way only actually we have defined all these diseases. Initially there was no naming of this disease. I think that is quite sure, you can accept this fact. Then obviously the naming, the part of naming was there, although there may be very, very close association between two diseases also. Means the two group of data may have some very close association, but some very interesting particular variable is actually defining for which these two symptoms are actually forming two groups. For example, suppose I am giving, I have already given you the example of this guava and mango. So in some sort of projection, you will find that guava and mango, it is very hard to actually differentiate between these two. Human also fail. So obviously, if somebody tell me that no, he has supplied these images, that this is guava and this is mango, then obviously you can try to find out a particular system variable through which you can differentiate this guava from this mango, maybe from texture variables. So it happens that initially we have no knowledge about the groups, and if somebody is there who has acquired this knowledge about these groups, and obviously before that he himself he himself was associated with this particular task, that I have to find out some groups out of this, otherwise it is very difficult to actually understand, means to discriminate between these two. Then obviously that is the exercise you are doing through in an unsupervised manner. Then how you are doing it? By finding out the distance between two data, and by finding out the closeness and kind of dissimilarity between these two data in terms of distance only. Means you are actually creating some sort of threshold distance, and you are thinking about a threshold distance within which, if two objects are there, they will be considered as closed, and if they are actually away from this distance, particular threshold distance, it is more than that, then obviously these two objects will be considered as actually not distant object, they are actually away from each other, so they are not forming a group. So this is the way of actually formation of groups and unsupervised learning. And once groups are formed, some experts are actually have accepted that, yeah, these groups are quite good to represent the actual fact. Then obviously that is well accepted. It is actually referred as classes. Once the groups are actually accepted by experts, these are referred as classes. And then comes the means grouping is actually referred as clusterization or clustering, and it is referred as unsupervised sort of learning. And once classes are formed, and your task will be to find out the association of any data, means that is in our hand, for which the class of this data is not known. And then class informations are already there. We will actually calculate the distance of this particular object from each and every class, and the closest class will be assigned as its class. So that is the classification task, and this is called supervised learning. Supervised because the class information is already supplied to you. I think this is quite sufficient for this time. I'm going.
Yes, sir. Yes, sir. Sir, one more question from Miss Sandhya.
Okay.
Yeah, what is of CNN and LSTM, CNN convolutional neural network,
Can you
and
repeat? I
LSTM?
could not hear you properly. Can you repeat?
Yeah. So, what is the significance of CNN
Properly. Can you send it through text? Can you please send it through text?
Okay, okay.
cannot hear you properly.
Yeah, sure, sir, sure.
The audio is missing actually.
She's asking that what is the difference between convolution neural network and long short-term memory (LSTM)?
Pardon? Convolutional neural network and
LSTM, long short-term memory.
okay, okay. See, I hope that you have ample knowledge of artificial neural network. Is it so? I hope that you have ample knowledge of artificial neural network.
Andhya,
Actually,
please
what
reply
happens-
on chat. What sir is asking?
Well, I'm trying to describe it in a short, because actually I am dealing with a fundamental thing of this machine learning over here, and these are the advanced part of this machine learning. And over there, this means to understand convolutional neural network, we should understand neural network first and how neural network works. It
And sir,
fundamentally learning.
in next lecture it will be covered. In fact, tomorrow's lecture is on neural network, and then day after tomorrow there is a dedicated lecture on convolution neural network.
I think it will be better to wait for that. Otherwise, if I find some time after my lecture is over, then obviously I will also try my best. Okay. So let me finish this.
Yes,
lecture.
yes, sir. You can move ahead, sir.
Time is not so much right now. Yeah. So this abstraction of input data, where I was discussing over here, actually that is the problem I faced each and every time, that some students, they came with a project, they have applied some convolutional neural network. Then when we have started asking about neural network, he is not giving this answer. So instead of actually roaming through so many very high-end sort of applications, so we should know the fundamental first. That is my actually motto, because for many problems you will find that this fundamental sort of kind of mechanism, fundamental models, they are actually working very good. So when and where we should actually apply those particular techniques, means especially these higher-end techniques, we should understand that. And there will be obviously a question that why you are actually applying those convolutional neural network or deep learning based mechanism, what is the need of that? So all those things will be there. So obviously, I think you should know about the fundamentals. So you will find that these fundamental models are actually solving many problems without being bothered about all these things. Because currently the feedback from the brain science community is that human brain is actually doing some sort of Bayes learning only. Previously, means when we were thinking about in terms of deep learning, we thought that it is actually doing something by gradual sort of extraction of knowledges, what we do in case of deep learning. But right now, the brain science people, they are giving a feedback that it is a simple Bayes sort of learning. So just think this Bayes learning is a very fundamental sort of model in machine learning. So it is simply like that. So again, now we understand the dimension of the data. Means dimension of data is very important to actually understand the data space. And we should have, as a person, if we want to demand that we have some sort of working knowledge of machine learning, or if we want to demand ourselves as an expert in machine learning, then obviously we should have the ability to visualize everything within the data space, especially the featured data space. Means what is the featured data space, and then obviously what is actually happening over here, how the two classes are, whether they are very much close to each other or overlapping. And then obviously all these issues should be very much clear to us if we have the ability to visualize everything within the featured data space. So that ability should be there. Next. So if we can visualize the data, suppose two-dimensional, it is a two-dimensional problem, then obviously there is nothing like that we can understand it readily. I'm showing you one example for that. Just 1 second. Please see these two examples. One is actually, we are actually facing the task of grouping the data. And now we understand that in the figure A, the grouping is not proper. It is having a lot of overlapping. And in figure B, the grouping is quite good. Each and every group are quite separated from each other. So from there, we can readily understand that which kind of grouping should be there. If it is two-dimensional, it is visible. If it is more than 3 dimension, then obviously it will not be visible to us. Then obviously we should know how to deal with this type of problem with the help of group evaluating or cluster evaluating parameters, measures. So we should know about that. Those parameters should deal with the particular aspect of the within cluster scatter, that is actually going to give you the understanding of the concentration or density of the data within a cluster. If it is of more density, then it will be really good, because that means that data are very much close to each other. It is actually forming a group. And then obviously the cluster to cluster distance means center to center distance, or maybe some other criteria of distance may be followed over there. And if you just have a kind of ratio of these two things, means within cluster scatter divided by the average cluster to cluster distance, then obviously it is going to give you some sort of ratio, from which if the ratio is very high, then obviously the clustering is not so good. If it is less, then obviously clustering will be very good. So from this, mathematically also, we can define whether within the data space, the groups are good or bad. Next is actually, once these groups are formed, and we know we have given the tag of these groups, name of these groups, then we form the classes, then this is the first step of the supervised learning. Now we understand that if we want to measure the closeness, similarity, so distance is actually coming to our help. And for this, various distance metrics are there. We already know Euclidean distance is known to all of us. And then there are Hamming distance, Manhattan distance, Minkowski distance, and you can explore it. And I think many of you already know it. Euclidean distance may not be a very good idea, because Euclidean distance is nothing but something like sky distance. Means you are actually not bothering about the actual road or path through which you have to move from one point to another point. So you are not bothered about that. But actually, in some cases, it may be the case that it is not a sky distance. You have to actually be bothered about the actual road through which you will move from one point to another point. If that is the case, then Manhattan distance may be the better one. And sometimes, if these two are not working, then obviously you can try Minkowski distance also. And Hamming distance is actually the distance between two strings that can be defined through Hamming distance. So that is also a special type of problem. If you are actually presenting your data in the form of string, then obviously string to string distance can be measured through Hamming distance. So these are the distance measures. Now, in case of unsupervised learning, there are obviously two types of methods predominantly. One is statistical or rule-based, and another is soft computing or human-like computing. That means through experience, iteratively, we are actually coming closer to our goal, to our solution. If it is the application of some iterative steps, methods, like human, we are actually making some error, means suppose you have been presented to me that somebody has told me that this person is Prakash. Then second time actually the same person, that means you have actually come to me. I told you, hi, Utpal, how are you? So you are not, so I could not correctly actually identify you. That may be the case because you and Utpal are having a lot of similarity. So I have made a mistake. But third time when you came, then I readily understand that you are Prakash only. So by repeated presentation of the data, and then I am actually minimizing my error. So that is actually main kind of philosophy behind this soft computing. And if it is one-time calculation, then it comes under statistical or rule-based sort of mechanism. And in many cases, we find that this is also quite a good sort of kind of model to apply depending on the context of the data. If within the data space, the classes are quite well separated from each other. We got a very good feature, suppose. Then if the classes are well separated from each other, then what's the fun of actually applying soft computing method? What the fun of actually applying deep learning and all those methods? There is no need. Only rule-based sort of mechanism will work very well. It may be you have to find out the class center and you have to define the class radius. And if this particular object is falling, its distance from this particular class is actually less than the class radius, then it will be regarded as falling within this class. And readily you can discriminate one particular data from another particular data. So that is the rule-based sort of mechanism to find out the class of one particular data. That is for supervised learning, obviously. And for the initial formation of the groups or clusters, that is unsupervised learning I'm talking about, then obviously you have to think about a mechanism. And then if you again go back to this bucket full of vegetables and you are picking one data after another data, then obviously at that moment, each and every time you are trying to find out the closeness between these two data. And if two data are actually found to be very close to each other, then we can actually conceptually think about the group of these two data are same. So that is the mechanism we apply normally. And following this comes the hierarchical clustering method, and then K-means clustering method. So one by one, you are actually taking the decision, putting the particular data within the particular group, following the close association between these two data. So it comes under statistical or rule-based sort of mechanism. And you are doing it for one time only without being bothered about suppose kind of overlapping between two groups. And overlapping between two groups, if that is the case, then obviously we have to go beyond the especially rule-based methods. We have to enter into the statistical method at that moment, maybe probabilistic methods. So we have to consider all these things. And maybe we have to enter the soft computing methods where we are committing the error. And then we are actually trying to find out some decision which will be error-free. So this is the basis of doing all this sort of rule-based or statistical or soft computing based model to find out our answers of either grouping or classification. Similarly, supervised learning, I have already described nearest neighbor. Nearest neighbor means if you are actually thinking about particular data which is already there within the classes, and that is very close to your target data, means for which the class is not known. and you are actually computing its distance, this target data, its distance from not only class center, because class center may be a kind of confusing sometimes or maybe misleading, because it may be the case that it may not be the case that always you will get the classes of shape, spherical shape, or maybe some Euclidean shape. It may be of some other shape, maybe of rough shape. Then obviously what happens that it will be quite better instead of center, if you actually compute the distance from all the points uh, across all the classes, then obviously the particular point which is very close to this target point, if you can identify that point, then obviously because this point is already within our known classes, so we can identify the class also of this point, closest point of our target point, and we can assign the class of this target point as the class of this closest point. So that is the nearest neighbor sort of method. Then comes Bayes, that is probabilistic association, and Bayes and HMM, actually, I don't think that I will find some time to discuss right now. And then comes soft computing based method, human-like computing, like whatever one of our learner was asking about this convolutional neural network. It falls within the scope of this soft computing based method. Human-like computing, although we were thinking at that moment that human-like computing was like this, but right now it is found to be different. But even then, it is obviously kind of progress we have made. Starting from artificial neural network means we found that it is very difficult to actually mimic or copy the actual neural network system that is there within our brain. And we thought the simple sort of model of these neural networks, and that is actually making our artificial neural network, because these are not exactly actual neural network. It is a simplified copy of the actual neural network, so it is called artificial. Then comes support vector machine, and obviously deep learning, whatever you are actually referring, convolutional neural network. Convolutional neural network, obviously you should know neural network very well, only then you can understand this convolutional neural network. And over there, we think that we should not be bothered about the feature. Nobody will actually help us to detect our feature. Means our model will actually detect the feature automatically from the means system or our items, our objects, and over there you can now understand that it is actually a mixture of knowledge discovery as well as supervised learning. So it's a mixture of these two. And we think that for some cases, some problems, we found that it is working much better than the means kind of very simplified models. So that is one particular thing. Another is actually for any model to work better. Now we may try to understand what is the role of optimization over there. As I have already told you that, especially for the case of this soft computing method, it is kind of copying the human nature, that learning from mistake. So through iterative steps, you are actually minimizing this mistake, that is error, and you are actually learning it better. So this formalism we are trying to copy over there, and this optimization actually having the great role over there, because optimization in its definition, we know it very well that optimization is something which is dealing with identification of the best solution. Best solution. The best solution means, suppose we are trying to find out the particular problem is something like for a particular function, we are trying to find out the minimum value of this function. Why? because this function is actually representing some sort of error. So our target is to minimizing this error. And we are actually changing the value of variable to see at which particular value of this variable this particular error is minimum. So obviously, if it is a kind of unimodal problem, the function is unimodal. That means means it's a single variable function and not single variable. It is having only one minimum. So if it is something like that, then obviously there are some ways through which we can reach to this minimum. Which means we can find out the value of the variable for which this function value is minimum out of so many possibilities. So, and even if the function is very, means output is very rough, even then we can try to find it out. And even if it is actually having a lot of means minima, it is not only a single minima, it may be multiple minima. And among this, actually, we have to find out the global minimum and this minimum of this minima. Then obviously, what there also optimization technique will help us a lot. And then now we understand that if it is only a unimodal function, then we will get only one solution. And for this, we refer it as a local solution because if you, it depends on the starting point only. Means if you are somewhere and you are trying to find out the minimum, you have to reach the value of the variable where it is minimum, then you will find only one minimum, and then your search is actually stopped. So obviously, for this particular problem, we get only single minima, and we stop over there. But if we know that this solution is not so easy, it is a complex one, it is having a lot of minima, then obviously this local sort of method, that is steepest descent direction method, I think many of you may know already, steepest descent direction method. It is actually nothing but to find out the solution with the help of mathematically speaking, to actually think this solution in terms of your first derivative. Means first derivative, means if you equate it to 0, then obviously this 0 will actually correspond to some minima or maxima, and from this equation you can actually solve the value of the variable, and then you can think that this value of the variable is your tentative solution, and then you can try to find out the next solution through iterative methods, and that is actually giving you this steepest descent direction. And this solution may not be the final solution, for the presence of so many sort of minima over there. So obviously you can try to find out the global solution, and for global solution, some very beautiful methods are there. And one of these beautiful methods is actually genetic algorithm. Very interesting to know. So all these things is actually these optimization methods, we should know that also. If we want to know the machine learning holistically, then we should know the optimization method also, because this value of the variables are very important, which will actually work very well for us. And in this case, whatever variable I am referring to is not the variable system variables. Don't confuse it with system variables. I am actually talking about the model variables, which we normally refer as model parameters. Like in case of the first example I have given to you, the simple straight line, over there, we understand it very well that these parameters are nothing but y equals to mx plus c is a straight line. So the variables are actually, these model variables are m and c. So if you can solve the value of m and c for which the standard line is giving you the minimum error, so that will be the best standard line, and that can be considered as your solution for your model. So this is the example of this model parameters that we can actually try to optimize for some goals. One is actually that will actually give us better output. With this goal, we can get the better output, minimum error, And then another goal is actually to compensate the data inefficiency. Sorry, data insufficiency, not inefficiency. We can compensate the data insufficiency, means data is not sufficient. At that moment, whatever model we have built is not actually giving us a very good model. Then the test data, we are getting a very bad efficiency. So that efficiency can be considered as our function score. And to enhance this efficiency means it will be a maximization problem at that moment. Means optimization may be minimization problem or maximization problem. It may be minimization of this error, or it may be the maximization of the function efficiency or the model efficiency to detect or identify the cases correctly. So we understand the need of optimization for this. So optimization is a very good method. We apply it for especially our higher end models, and for lower end models also we can apply it by applying our presence of mind, by looking into what are the model parameters over there, then we can try to apply optimization technique over there also. So thanks to all of you. I think I have finished within time. And if there are questions, I'll be very much interested to get those questions.
So, any participants who want to ask questions, he or she can put that question on chat board, please.
Questions should be restricted from this discussion only. I will prefer that.
Yes, sir. Yes. Sir. So, thank you, sir. I think there is no more question right now. Any question from any participant?
There is a question on support vector machine, but I think there are two dedicated sessions for in fact, 3 dedicated sessions for support vector machine. So that will be
It will be a redundant discussion then. Yes,
that will be dealt there. And sir, one thing that you have covered very well, the basic concepts of machine learning and artificial intelligence. You have also thought about the optimization techniques, etc. And we have designed the module in such a way that one particular session is dedicated to heuristic and meta heuristics. So
great.
That will be dealt.
It is quite great. And what I should say that if there are really some questions, then I will be available always through my emails, and that email can be shared by the organizers to the participants. So I have no objection on that.
Okay, over. So Upen sir, please.
Okay, sir. Thank you very much, sir. It was very interesting and knowledgeable lecture, sir. I hope all the participants have benefited through your lecture, sir. It was basically based on basics of machine learning fundamentals, and also how to utilize the supervised learning and supervised learning. So finally, how to optimize these functions. So basically, you have covered most of the basic part of machine learning methods, sir. Thank you very much, sir. And we hope this lecture was very fruitful. This would be very fruitful for all of us, for all the participants who have joined here. Thank you very much, sir.
Thanks.
Thank you, Professor Devrata, sir.
Sir, anything is?
Yeah, he wanted.
Sir, anything else you would like to say here?
Yeah, he wanted to.
Yes, sir. Yes. Yes, sir.
So, Professor Devrata, this is a small, sort of token of respect certificate which we have, shared digitally.
Thank you, thank you. I am very much pleased and feeling privileged for getting the certificate from you.
We would be separately sending you through email also,
thank you,
along with one form which we request you to kindly fill. And thank you so much for sparing, more than the time which we expected out of you, and that is a generosity of academy.
No, we academicians have this duty, I feel.
Though are critically respected, but they are very, very generous like you. And thank you so much for sharing the word of knowledge and wisdom with in the area of machine learning and artificial intelligence broadly. Thank you so much. And I think for the candidates who have joined us today, we request they to use the same link for joining tomorrow. And tomorrow's session would start at 10:30. Pavanji, Upenji?
Yes, sir. Yes, sir. 10:30.
Yes, sir. It will start.
10:30.
Yes.
Session would start at 10:30.
10:30. 10:30.
10:30, but we request the participant to join at 9:15 so that that session is not being disturbed and they to join in time. So kindly do join at 10:15. Session would start sharply at 10:30 tomorrow. Thank you everybody for joining us today. And I assume that, I believe that it has been a wonderful session, both session today, session of Python and today with Professor Devrata also with machine learning and the fundamentals very strongly explained to all of us. Thank you. Thank you everyone.
Thank you.
Thank you, sir. Thank you.
Bye bye. Leaving the Zoom.